Hello everyone. This is one more interesting question that is related with structural geology, and this question came in CSIR NET exam in 2025 in June. Okay, and I have seen that some of the students got difficulty to understand this. Okay, that's why I have taken this question for understanding. Okay, apart from this question, if you have any query or how to prepare for CSIR NET exam, anything that you want to know from me, I'm ready to give it to you. Okay, and please ask question to the system from wherever you are learning. Okay, and don't wait for the opportunity. Opportunity will come and go if you are ready. Only then you will achieve. Okay, so don't wait for that. Okay, so now coming back to our question. This question is how you read a map. Okay, this diagram how you interpret it. Okay, and we will we will not read this diagram in the starting. Okay, how this diagram is created, we will go step by step. Okay, so that our concept will be clear in this. Okay, the person who, because from the first step to last step, how this diagram is created, what are the tectonic activity, what are the things are happening with the strata, so that we will get our this final output. We will go one by one. Okay, in cross section as well as in plane view. Okay, both way we will go. Okay, and okay, so now suppose our original data is horizontal. Okay, our original data is horizontal. Okay, this is which view? This is cross sectional view. Cross sectional view. Then what is plane view? This is our plane view. Okay, and we are marking north on it in this direction. Okay, okay, now I will make 3D of this. This is the first step. Okay, step 1, this is in a basin, the sediments are got deposited. Okay, now in the second stage, okay, what is going to be happen? Okay, we apply force on this strata. Okay, so now this strata is getting fold. In second step, this strata is getting fold. If the force is applied from this side and this side is equal on whole length. Okay, so then we will get a 190 line in incline pattern, and it is extended in extended. This is the in zone. We're getting incline incline in this way. Okay, top one is our plane view, this one is our cross sectional view. Okay, but if force is not similar, okay, suppose in the northern side force is less and in the southern side compression is more, so then at that time we will get what, if equal force is applied. Okay, in this case equal force. Okay, but if force is not equal in north and south, southern side have more force, then we are getting what, we are getting anticline here, but we are not getting less compression here na. This side we are getting well developed. Okay, but this side we are getting a from this side it is difficult to understand, okay, because it is a plunging fold, okay. So we'll make a cross section of the we will see from this side, okay. Now it is like this. It is like this. This is our plunging fold now, okay. This is one case. This, okay, same. I'm not changing anything, okay. I'm just changing the force, okay. Then what is going to happen, okay. In this case, hinge line and fold axis is horizontal. Hinge line and fold axis is horizontal. Why I am saying this? If I erode this top now, suppose I will erode this part, okay. I will change the color. Suppose I will erode this part, okay. Now this is my plane view now. This top one is my plane view. Then this curve will shift it to now. Suppose it cut here, okay. So now, okay, I will join this point and this point, okay. Any similar we will get a line. I will extend this little bit, okay. This line itself is our batting list, okay. So now what we are getting? We are getting like this. We are getting like this. Okay, this side our data is dipping toward this side and this side our data is dipping toward this. So we'll mark in this way. Okay. Okay. Now in this case, if I will cut from here, mean erode or cut from here, okay, we will get a, we need to get a plane view, no? You need to get a plane view for this also. But in this case, we are not getting like straight lines as we are getting like this in this, no? Because why? Because our beds are plunging in this case, okay. In plunging, our lines are getting curved now. How? If we from the top, we have to see this, okay. Okay, we will cut this. We'll get in a plane view how we're getting curve like this. We are getting a curve like this. Suppose this is our north now. I'm just rotating this, okay, to understand, okay. Now from the top we will see it, we will get curve like this. Now if I will make 3D of this, I will make 3D of this for understanding, okay. And one more layer I will draw, okay. So I will draw one more layer, okay. If I will move from this part to this part, okay, from this part to this part, okay. Okay, from this side, now we are getting the curves, similar curves like this. This means this bed boundary. Okay, now similar curves are we are getting here also. No? So now, if I will look at this part, here we are getting how much angle? 40 degree toward this side, toward this side, and similar way we are getting this way. Okay, so now the confusion is what we are facing in this. We can construct here, okay, it is like this. In a similar way we have getting on this phase also, no? Because it is dipping toward this, so we have to construct. You are thinking that it dipping toward this, we have to construct in this way, okay. but it is not dipping in toward east, west. It is dipping toward north west. But if I want to construct this in west direction, I mean, this suppose this is our true dip. This is our apparent dip now because it is perpendicular to this now. This is apparent dip. So this angle will be less in this case now. So in this way, we are constructing this. Okay. So now, are you able to visualize the things? In first step, orbits are horizontal, then they are folded, they are dipping toward. In general, if we consider they are dipping toward north, okay, due to folding, okay, and this fold is a plunging fold, okay, because it is in a plane view, okay, and it is a plunging fold, okay, and other thing is we have constructed the two cases where we are getting a horizontal limb as well as a horizontal fold axis, then we will get parallel lines, okay, but we are getting a curve lines on the plane, so it means our data is plunging, okay. Hinge line is a maximum curvature partner, and fold axis is also in the same direction, okay, but it is not horizontal in this case, it is plunging, okay. We have some angle, okay. Now one more tectonic activity took place, and it is took place in this direction. One change, I will change the color. So now one more movement took place, okay, within this. Okay, now we apply a force, okay, on it, okay. So now what is going to happen? I will construct two-way movement, okay. One, I will stand over here, and I will see that this block is either going this way or this way toward right or toward left. One side it will go now. So we will construct both the cases, okay. So what are the changes we will observe on the plane view in both the cases? We will understand that, okay. First we will understand plane view, then we will go into cross section also, okay, for this. Okay, so now I will take only this curve, okay, single curve, okay. So now I will apply that Stike's fault, and this is our curve. Okay, this is our curve. Now it is shifting toward our, I'm standing over here and it is shifting toward our left. It is shifting toward our left. But if we shift toward right, then it is like this. This is a plane view, okay. What is going to happen within the cross-sectional view? This side we will construct one cross-sectional view, no? Then what is going to happen on this side, okay? This is Stike's fault. What is happening on this side? Okay. If you are able to imagine that thing, then you are understanding it properly. Okay. And in a similar way, because we are seeing Stike's fault on a plane view, is this a similar thing in a cross-sectional? Okay. Or what kind of fault we will see and we have to interpret it, okay. In cross section we may see in as a normal fault or a reverse fault, but their movement will be horizontal, that circle lines will be horizontal. From that we will interpret this, okay, that it is a strike slip fault, okay. Otherwise it seems like a normal fault, okay. One block is up and one block is down, or one block, okay, reverse is also the case, okay. Suppose here now I will zoom out this part, okay. Now zoom out this part, okay. Initially suppose our curve is like this, okay, this curve. Now fault is coming like this now. Fault is coming like this, okay. If the dipper mode is same, okay, then what we will observe? We will observe if dipper mode is same, okay. We will observe this. This block is going this side in 3D. Another color. This block is going this way. This block is going this way on the top. Same thing, but if body dipping is same, okay, in that case we will see in this way, okay. And there is more thing I can add in this, but I don't want to make it clumsy, okay. And we have already reached to our answer, so we will discuss that. And if you have any query regarding this, and if you feel any difficulty in any part now, you just tell me, okay. I will explain without question the whole concept, okay. So now coming back to our options now. First option is, now you will construct directly over here this. If I will stand over this line, I will clearly see that this line is shifted toward our left. Okay, now if I will stand over here, I will clearly see that this line is shifted toward right. We will put arrow like this. Sorry, left. Okay. If we will look from this side also, we will see the left side. Okay. So in a similar way, this. So this is our left lateral sense or sinistral sense. Okay. When we are standing at one place and our side is moving toward our left, we will say left lateral or left sense or sinistral sense. Okay. And it is a plunging anticline, plunging anticline, and plunging toward which direction? Plunging toward north. Okay. And now this question already came now. So now in next time if they will ask question, in which way they can ask. Suppose this is now in anticline now. Now suppose it is in that sin form. In that way also you have to understand the things, okay. Okay, now you just change the dip of this. Now it is dipping toward this side and this side. Now you just shift the this side now. Now what you will understand from this, that is important. You have to reverse the case also, okay, and add some more cases so that you can interpret it very well, okay. Next time if they change little bit, you are able to answer that time, okay. Don't go with just diagram and answer this is the answer. No, no, that is the wrong thing. Okay, in structural only, otherwise after giving exam now your question will be wrong if you don't have a concept, okay. With that concept, it is not possible to answer, okay. Especially for structural geology, okay. Basic question you can answer, just remembering the things, okay? But this diagram based questions is not that easy, okay? So now our option is, this is a strike slip fault, okay? We will got horizontal silicon lines on this, okay? In cross sectional view we have already seen, okay? So our answer is this one, strike slip fault, an antiform with sinister sense of movement. I will add one more thing, that plunging antiform, okay? Why I have written anticline, okay? They are written antiform. What is the difference between anticline and syncline, okay? What is the difference between that syncline and synform? What is the difference between window, nappe, clipe? One more term is that syn antiform, plunging synform, syn antiform. These are the terms that will come in exams mostly, okay? So if you want a video on that or any other video that you feel difficulty in any part, you will ask me, okay? We will discuss those things, okay? But discussion is very important, okay? Okay, hope you learn something from this video. And if you have any query or something, you can put in the comment box, okay? And share this video with your friends, discuss among each other, discuss with me also. Wherever you are learning, discuss with them also. Ask question to the system and be ready for the exam, okay? Exam will come and go, I already told in the beginning, okay? So okay, thank you.